All right, what we're going to do right now is we're going to take notes on Chapter 3 from Stats Modeling the World. And this chapter is going to focus on comparing means. And so this will be when we do 2 sample t-test and 2 sample t-intervals. Okay, so when comparing means, we use the 2 sample t methods. The corresponding hypothesis test is, if we actually do a test, is called a 2 sample t-test. Whenever we're doing a difference of means, remember we always start that there's no difference, and so we're always going to do the mean of one sample minus the mean of a second sample is equal to 0, because remember hoes stay the same, there's no difference. Usually what I'm going to do to make it so I don't have to worry about negatives as much is I'm going to usually find whatever one has the bigger mean, that's the one that I'm going to do first. So usually big minus small. All right, so when we have to find the standard deviation for the difference in the samples, remember our standard deviation formula is the standard deviation over square root of n. But I'm going to have 2 different samples. I'm going to have sample 1 and I'm going to have sample 2. Oops. So remember when we dealt with means before, we had to square them and add them and take the square root. So essentially what we end up having is the square root of the standard error from the first sample squared over n, because squaring a square root cancels off, plus the same thing on the other one, but dealing with the other sample. To find the margin of error, remember margin of error, if I have a confidence interval, it's just the half. So it's half of confidence interval. And so it's to calculate the margin of error, it's critical t times the standard error, which is that big thing right there. Don't really want to write it all again. Okay, so now let's look at our conditions. And so we have the same conditions. It has to be random. So you have to ask yourself, I'm going to make this a little bit smaller, are both samples random? Do both samples represent less than 10% of population? Are both samples independent from each other? And then remember the nearly normal. This is when we're going to look at the histograms. And we're going to, if it's large enough samples, then it doesn't really matter if it's skewed. So if sample's large enough, it's okay to be skewed. Okay? All right, so what we're going to do now is we're just going to look at some examples. Oh, they're not there. Hold on. Okay, what I want you to do is we're going to look and we're going to compare the sugar content for national brands of children's and adult cereal. So I'd like you to start off by plugging in children's cereal into L1 and adult cereal into L2. And then once you have that, we're going to determine the mean, standard deviation, and sample size for each one. So we got kids cereal, and then we have adult cereal. And for each of them, we need the mean, the standard deviation, and the n. And remember, you can find that by finding 1 vars. So 1 vars. So stat, go to calc, and then choose number 1, 1 vars. Okay, so go ahead and enter those in and see if you can find your mean, standard deviation. And okay, so these should have been your mean and standard deviations that you found and the sample size. And then the next thing we had to do is we have the check conditions. I went ahead and wrote them out. We'll talk about the last one. So assume random cereal brands are chosen. It does not say that they're random, but that's why we're going to say assume. Sugar content is independent from other brands. 19 and 28 is less than 10% of all brands of cereal. Now the histograms, they're both roughly unimodal. One is skewed, so we could say and large enough. So let's look at the pictures. The one that's going to give us problems is this L2. L2 is definitely more skewed and it has this possible outlier, but it does have a relatively large sample size at 28. And so because that sample size is pretty large, we should be safe to go ahead and proceed. Let's look at the scatter plot of kids cereal. So we got to go to L1. And then zoom 9. Okay, that one's better. Still skewed, but not a ton. It is unimodal, and because it's a sample size of 19, that's not super small, so we're okay. So that's why we're able to go ahead and proceed. Okay, so now we're going to run a 2-sample t-test. So the first thing we need to do is we need to write our ho and our ha. Okay, so remember your ho's never change. It's always the same. So there's no difference in cereal content between kids and adult brands. Okay, so remember we want to do the bigger one first, and let's see, I'm pretty sure it's the kids. Yeah, kids is much bigger. So we're going to say the mean of kids minus the mean of adults is equal to 0. And then your ha, let's see, what does it say? Does it say that it's more or just is a difference? Okay, so it doesn't say, so because it doesn't say, we're going to say that there is a difference. So we're going to say there is a difference. Now, it definitely looks like one's higher than the other, but we did not see that it's greater. So we're just going to say, oops, I didn't mean to write the minus. Kid cereal minus adult cereal does not equal 0. So that's going to turn this into a two-tailed test. Okay. All right. Oops, there's my phone. Hold on. Okay. So conditions have already been checked up here, so we don't need to run the conditions. So what we do need to do is we do need to draw a picture. All right. And remember, your mean is always based on your hypothesis, which is 0. Now we need to actually find the difference between these two. So we need to do 46.8 minus 10.14, or 15, sorry. So 36.65. I don't even have to run a test. I know that that's super far away, but we're going to do it anyways. And remember, it's two-tailed, so we're going to do this, okay? Now, we do need to say what kind of test we're running. We're going to run a 2-sample t-test with degrees of freedom equal to something. Now, this is where we can't find it. Degrees of freedom has a complicated formula for 2-sample t-tests, so we don't do it. We let the calculator do it for us. Okay? So let's do our calculator. All right, so we're going to go stat, test. We're going to go down and choose number 4 because that's a 2-sample t-test. Okay, we hit enter. Now, we have data, and our data is already in L1 and L2, and we are saying that it's not equal to. So I'm going to hit enter. It's not pooled. You're not going to have any pooled to worry about this year. And then we're going to calculate. Okay, so this number right here, that's our t value. It's 17.8 tick marks away. This is our p value, 0.000. There's 20 zeros. So let's see if we can write this down. So we got a p value. Whoa, that's a super thick gray marker. I don't want that. Let's make that thinner. Okay, so we got a p value of, I already forgot, 2.14 times 10 to the negative 20 something. 21. Let's see our degrees of freedom. Where we go? Right here, 42.77. So we could just say 42.8. And so now we have all the information we need. Okay. If we wanted to list our standard error from the sample, I do want to do this so we see. Let's see, we're going to scroll down here. And these are our two standard deviations, 6.4 and 7.6. So we have to do 6.4 squared, 7.6 squared. 6.4 came from the first sample of kids, which was 19. And this is 28. You don't have to show this step, but if you have a problem asking for the standard error, I want to make sure you guys recognize that you can get some of the answers from the calculator right here, but then you still have to square them and divide them by the sample size. Okay? All right, so now, let's actually just write what that is. So, 6.4 squared divided by 19. I'm doing it on my handheld calculator versus the computer because it's a little faster. So you should get 2.05. Okay, but really, whoa, I did not mean to zoom in like that. Ah, hold on. Okay, but really, the main thing we have to do is get this. And so, with a small, I should probably... let's use a different color for the summary. Sorry, I wrote all of it and I'm erasing it. Let's use purple. With a small p-value of 2.14 times 10 to the negative 21, we reject the null. There is strong evidence that there is a difference. Run out of space. In sugar content between kids and adult cereal. Now, in a second, we're going to do the confidence interval because we know that it's there was a big difference, so we're going to do the confidence interval. I do want to mention one thing, though. In the past, when we had two-tailed tests and we were doing normal CDF or TCDF, we would have to multiply it by 2. But when we ran this test, let's run it again. When we ran this test, a 2-sample T, oops, we said not equal right here. And because you say not equal right there, it goes ahead and it doubles it when it's calculating it. If we changed it to greater than, we're still going to get a really small p, but it's going to be half as small, right? Because it was 2.14 and half of that is 1.07. So if you have a two-tailed test, when you're running your t-test using the calculator function, it will calculate the p-value correctly. All right, so now what we're going to do is we're going to do a confidence interval. And again, I said we can use our new test program on the calculator. So we're going to run a 2-sample t interval see where it's at. 2 sample Z, nope, 2 sample T, that's what we want. We're going to hit enter. Everything's in L1 and L2. We're going to stay with 95%. And calculate. Okay, so it's 32.5. So 32.5, comma, 40.8. Now, you notice how this is always positive? Because it's always positive, that means that kids' cereal is always higher than adult cereal. If it went from a negative number to a positive number, then that means sometimes adult cereal would be higher. But for now, because it's always positive, that means kids is always more sugar content. Okay, so we are 95% confident that kids' cereal will have an average, an average of 32.5 to 40.8 more. Is it grams? How are they measuring this sugar? Let's see. I didn't even say. Oh, percent of weight. Yeah, sugar content. More sugar content than adult cereal. Just moving all my words together. Okay. All right, that's it. So the biggest thing you have to do is practice using the correct test. Same conditions, same process as everything else. It's just now we're allowed to use a calculator, which in the end will make it a little easier.